Hello, and welcome back to another IB Math Speedrun with me, Vince. So today we're going to start Chapter 5 of the IB Math textbook, so let's jump right in. So, Chapter 5 of the textbook is all about statistics and probability. And yeah, this is quite important, and we need to learn statistics. It's one of the most important branches of math, and it can be easily applied to real-world scenarios. So, the first thing we need to know about is sampling. And to know about that, we need to first look at the different types of data. So, data can either be qualitative, which means it's organized into certain categories, and it's usually when you have to answer the question using words like how are you feeling today. You can't answer one, so how are you feeling today? You have to answer it like happy or sad or something like that. On the other hand, we have quantitative data. Quantitative data. And what is quantitative data? Quantitative data is numbers, more or less. It's data that's expressed in numbers. So instead of asking, how are you feeling today? I could say, on a scale of 1 to 10, how happy are you feeling today? And if you responded with like 8 or something high, which I hope you do, that would be an answer for quantitative data. So now more on quantitative data. Quantitative data can be discrete or continuous. So what does that mean? So discrete means that there are separate intervals, and so it's normally numbers that can be counted. So there's specific intervals for which this data can be. So normally it's like counting numbers, 1, 2, 3, 4. It's like if I asked you, how many t-shirts do you own? You can't answer with 3.5. That's not a valid answer. It has to be in one of these sort of categories of numbers. On the other hand, we have continuous data. Continuous. And this means that the data is in a range of numbers. So if I asked you, how tall are you? We would normally expect that to be in a range of like 1 meter to, 3 meters. And so your height can take any value within this range, and it doesn't have to be a specific number. So, and we can measure continuous data to an infinite amount of accuracy. So continuous data will always be inaccurate to an extent because you could always measure it more accurately, whereas discrete data is perfectly accurate because there's no way to measure how many t-shirts do you own more accurately than a certain point. Okay, so that's the first part. Now the second part we need to talk about is the difference between a population and a sample. So a population consists of every member of a group that you want to find out about. So if you want to find out what's the average size of a family in the city, then the population would be every family in the city. So this is like a population. And so a sample would be a small section of this population that will give us information about the population as a whole. We use a sample because obviously you can't measure, well, it would take time and lots of resources to measure the size of every family, possibly more so than the data is worth. So in order to to get a rough estimation of how many people are in each family, we take a sample, which is just a smaller section of the entire population, that will probably give us reliable information about the general population. So, how do we choose a sample? Normally, we want to define some things about our sample, and to choose a good sample, we need to get a group that's small enough to, realistically measure, but large enough to actually provide accurate information on the population as a whole. So to clarify how a sample is taken, we have to define some keywords. First of all, the target population. And this is simply the population. from which we want to take a sample. And then we have the sampling frame, which is the list of items, or like anything, the list of items within the target population from which we can take our sample. So this is effectively the sample, this is the population. Next we have the sampling unit. And this is a single member from the sampling frame that is chosen to be sample. We have the sampling variable, which is the variable under investigation. Of course, there can be more than one sampling variable, but this is the characteristic we want to measure from each sampling unit or each individual member of the sample. And finally, we have the sampling values. And these are the possible values of the sampling variable. And so this is like sort of defining what can it be? What can the variable be? So yeah, I guess let's jump into some questions, because that's all to talk about for this subchapter, well, I mean this exercise. So what we need to do is we need to define the target population, the sampling unit, the sampling frame, the sampling variable, can't spell, what in the world? And finally, the sampling value. Oops. Okay. And the first thing we need to define these all for is an investigation into the lengths of celery sticks grown in a certain US state. Okay, so what is the target population? The target population is the celery sticks grown in a certain US state. So we can write that down. The target population is the celery sticks grown in the state. Actually, I'm not going to write these out. This will take too long. I'll just put them in the text box. So this would be the celery sticks grown in a certain US state. So next, we need to decide on an appropriate sample. And well, I guess if we're investigating all of the celery sticks, the sampling unit. Oh, it's the unit first. Okay, so the sampling unit is each celery stick, a celery stick, because that is one part of the population and one part of the sample. So, what is our sampling frame? Our sampling frame would probably be all of the celery sticks in the state, or like a list of the celery sticks in the state. Okay, what's our sampling variable? Well, it's clearly the length of the celery stick. And what values can this take? Well, I'm not too sure how long a celery stick is. So the most general example is, well, is this quantitative or qualitative data? And it's clearly quantitative because we're dealing with numbers. We're dealing with a length. Is a length continuous or discrete? It's continuous, since there's no set intervals that a length has to be. So I would just say all real numbers as the sampling values. Okay, so that's done for that, and we'll do one more. So we need to get the volume to the nearest ml that a soft drink factory fills its 1 liter bottles of soda drink. So what is our target population? The target population is the factory's 1 liter bottles of soda. The sampling unit is each 1 liter bottle. And I guess the sampling frame would be a list of all the soda bottles. So that would be a reasonable sample. Our sampling variable is the volume of a 1 liter, or the volume filled of in the bottle. In the bottle. And our sampling value, well, we're given that it's to the nearest milliliter, so this can really take, I guess, the natural numbers, since it's to the nearest milliliter. So for measuring it in milliliters, this will simply be the natural numbers. Note that this is technically discrete data, since we're only measuring to the nearest milliliter. This has set intervals and we are not supposed to measure past them. So this would not really be continuous, this would be well, the actual data would be continuous, but what we're measuring is technically discrete in a sense. So yeah, that was all for the speedrun, and I hope to see you in the next